So, alright guys, good evening from this side. So I am your regular self, Eli Tutor. Okay. So now on this note, we are going to be solving the Olympiad mathematics. So these are outside Nigeria syllabus and partially part of it anyway. So every time it's not Nigeria. So wherever you are watching from, you can learn from this. Alright. They said solve the exponential equation 2 raised to power x equals to x raised to power 32. Hence, find the value of x. It is very simple. It may look tricky, but it's very simple. Alright, let's go. So this is what we are going to solve for, and we are finding for x. So in this case, what you do is that let's give what belongs to Caesar in a relation that let x goes for x and numbers good for numbers. That is, let constant variable goes for constant variables and let numbers add. So they are parting ways at that junction. It is very simple. Get along with me. How do we do that? Alright, you realize that this is what? This is my left hand side. No argument about that. You also realize that this is my what? My right hand side. No stress. So now, how do I let x goes for x, and how do I let this x goes here and let this 32 come here? I want to part them ways. Alright? So how do we do that? Let us start with x. On letting x to go here, what do you think we are going to do? We will just multiply the power of both sides by 1 over x. It is very simple. It's just like, for instance, you have 2 raised to power 2 and you have y. Okay, no, let's do it like this. You have y raised to power 2 and you have 2. It's just like you having something like this. If I ask you to find y here, what do? You square root what? You square root both sides. Alternatively, square root means what? Raised to power half. It's still the same thing as 2 raised to power half equals to y raised to power what? Half. Do you understand? Like, this one is having 2 before. Y square raised to power half. Then just take care of this. You have y left. So, if you don't want to say multiply both power side by 1 over x, you can say that x roots both sides. Let's start with that one. What do? X roots both sides. How do you x root both sides? That will be x root 2 raised to power x equals to x root x raised to power 32. Then this x here, don't forget. So we have x root both sides now. This one here, take care of this. It is gone. Okay? So now it remains what? 2 raised to power 1 is equals to what? X raised to power 32. You know, we can translate this one to the index form as 1 raised to power what? X. I think we are getting it. Alright. So let's proceed further. Alright. So now, at this junction, we want to also take this 32 to the other side, because we don't want this 32 to stay here. Remember I said let x be for x and numbers be for number. How do we do that? We are going to what? The next thing is, we have already x root both sides now. So the next thing is that what? With 32 roots both sides. It's not hard. Alright, 32 roots both sides. You now have what? Root 32 here. Then you have what? You have 32 roots here. Then don't forget that you have 2 here. That is carrying raised to power 1. Alright? The same thing here. You will also, what do you do here? You also do what? 32 root this side. Don't forget, I said 32 root both sides. So you also 32 root this side too. But this one, it does not affect this one. This one is still intact. So we are still having x raised to power what? 32 over what? Over x. Because if you multiply this power by this one, you'll be having 32 over x. It is still intact. Alright, so now translating this one to index form. So here you are having 2 raised to power 1 over 32, which is equals to, here, if you translate it to index form, x raised to power 32 over x raised to power what? 1 over 32. There is no stress there. Then this 32 take care of this 32. So we are left with what? X raised to power 1 over x. That is, it remains 1 over x here times 1. That's 1 over x equals to what you have here. 1 over what? 32. At this junction, what do you do? Oh, there's a mistake here. Equals to 2 raised to power 1 over 32. At this junction, what do you do? The equation is balanced. You can see that this 32 here is not equals to this x here. Like, looking at it, you have not gotten the value of x. Now, the only way you can know that you have gotten the value of x is, for instance, if you're having x equals to 2 and you're having 1 over x equals to 1 over 2, then you can say that x is common. You can just equate them to get your value of x. But as it is, we have to balance the value of x, whether for the exponential or the base. Alright, we proceed. Now, how do we do that? We are trying to balance the case. So that means x raised to power 1 over x equals to, this one is the same thing as 2 raised to power 1 multiplied by 1 over 32. Alright, which implies x raised to power 1 over x equals to, now since the base here is 2, so we turn this one to, you know, this one is 2 raised to power 1. Since it is 2 that we're having as the base here, it becomes 2 raised to power 2 divided by 2 times 1 over 32. It does not change what you have here. 2 divided by 2 will return you back to 1. It is because we have 2 here, that's why we are using 2. If it is 3, we'll be using 3 divided by 3. Are you with me? That is the rule. Now, don't cancel it. So, which is equals to what? Which is equals to x, which implies x raised to power 1 over x, is equals to what? Is equals to 2 raised to power 2 over 64. It is not yet balanced if you look at it very, very well. It is not yet balanced. Alright, we proceed. So, again, we are having 2 here. It also implies that we are also, the same procedure we approach here, like the same procedure we do here, we also apply it again until we get what we are looking for. So that means we are going to be having x raised to power 1 over 3, x again is equals to 2 raised to power, the same thing will repeat itself here. So 2 raised to power 2 divided by 2 multiplied by 2 divided by what? 64. Okay, we are getting there. It now implies that what? That is x raised to power what? X raised to power 1 over x is equals to, you multiply it, you're having what? 2 raised to power 4 over 64 times 2. That is 128. 128. We have not gotten there. We are almost there. So also, which implies that we will repeat the same process again. 1 over x is equals to, we repeat the same process we did here. So that will be 2 raised to power 2 again divided by 2 times 4 over 128. So now we now have s raised to power 1 over x is equals to 2 raised to power, this one is 8 divided by 2 times 128. 2 times 128, we are having 256. Now, looking at this question very well, it is very obvious that we have gotten our final answer. So now at this junction, you are having what? It implies that x raised to power 1 over x is equals to 2 raised to power 8. If you apply power law here, 1 over 256, isn't it? So then you are having what? You are having x raised to power 1 over x, alright, then equals to 2 raised to power 150, 2 raised to power 8 is also the same thing as 256 raised to power what? 1 over 256. Can you see that clearly? It is not hard. Now, looking at this, you will observe that you can either use this equals to this or this equals to this. X is equals to 256, or 1 over x is equals to, this 1 over x here can be equals to what we have here, equals to 1 over 256. Then this one take care of 1. It now implies that x is therefore equals to 256. So our final answer for this kind of question is what? Is 256. So I am going to be solving similar type of question in my next video. Don't forget to like, comment, and share. Get us a subscriber. I am doing a giveaway on the 25th of this month. So please get us a subscriber. I love you guys. Love you all.